Mamma mia, salut and welcome to this new video. Today we are going to demonstrate the formula of the maximum power transfer. Go ahead and calculate the maximum power transfer at RL, across the load RL. We know that the formula of the power P is equal to I L square RL, and the current IL itself is equal to ETF on RTEF plus R load. Let's call this equation 1 and this other one equation 2. And the only condition to get the maximum power transfer P max, the condition is to have the resistance of the load should be equal to the resistance of the source, which is here R def. That is the only condition that we can have in order to have the maximum power transfer. Let's call that equation number 3. And now let's take equation 3 as well as equation 2 and substitute into equation 1 and find that maximum power transfer. P should be equal to I square, I which is equal to ETF on RTEF plus RTEF again square time RL, which is here equal to RTEF. That is the only condition. That will be equal to ETF square on 2 RTEF square time RTEF. Okay, let me go down and get a small space. Now when we expand this formula very well, when we try to arrange this formula very well, we discover that P max will be equal to ETF square on 4 RTEF, because one RTEF here will cancel with this other one, and the remaining formula will be the good one. That is the expression to get the maximum power transfer. Now what can we happen if we have but instead of Thevenin source but the Norton source? In this formula we are first of all looking for the expression of the current I load, and from there we know that the formula of the power P will be still be I load square time R load. Now an I load alone is equal to, by current divider at this main current, because here is I Norton, here we divide it into two branches, that I load should be equal to R Norton on R Norton plus R load time the main current, which is here I Norton. Let's call this equation, let's say equation 1, this other one equation 2. And the condition to get the maximum power transfer P max, the resistance of the load should be equal to the resistance of the source, which is here R Norton. That's the only condition to get the maximum power transfer. Let's call that equation number 3. Now let us now take equation number 3 as well as equation number 2 and substitute into equation number 1 and see what we can have. Means that maximum power P max will be equal to I square. I square here is R Norton on R Norton plus R Norton time I Norton square time R Norton, which is here R load. Okay, if you have the question, don't forget to ask in the description section below. Let us continue expanding this formula. We discover that here we will give R Norton time I Norton square on 2 R Norton square as well time R Norton. This is P max. When you continue expanding this formula, we discover that P max should be equal to because this R Norton here will be cancelled with this other one. P max will be equal to I Norton square times R Norton divided by 4. That is the only condition that you can have in order to get the maximum power. Correct. If you have a question, don't forget to ask. So by conclusion, we can say that in order to get maximum power transfer, the resistance of the load should be equal to the resistance of the source. If it is a case of Thevenin, that RL should be equal to RTEF, and in the case of Norton, RL should be equal to R Norton, and that maximum power P max should be equal to E TEF square on 4 R TEF, which is equal to I Norton square time R Norton on 4. If you have a question, don't forget to ask in the description section below. I will be very happy to answer. And if you have any suggestion, don't forget to ask. Thanks for watching, and don't forget to subscribe. Have a nice night. Peace.